In this video, I'm going to show you how Logosoft works. Logosoft, first of all, it's a basic PLC programming platform or software supplied by Siemens. It is used to control specifically the PLC logo. In this one, I have the version 6. It's a bit outdated, but it still does the job. As you see here, before you can open new, you have two languages that you can choose from: your function block diagram and the ladder diagram. These are commonly used international standard languages. So I chose the function block. The beauty about this software is that you can interchange between the two languages. If you master one, you don't necessarily need to master the other. You can simply change, you can convert here. Alright, and then when I open this pane, you have your inputs, you have your outputs, and you have your text function key there, text display function key, and you have your flag, memory flag, and under here you have your analogs, your input output analog, and then here you have your basic functions, your end edge, and so on. And then you have your special functions, on delay, tentative on delay, and the counters, and more analogs. Then you have miscellaneous, which you have the latching relay and the pulse relay and messaging text and things like that. So in order to master these, you need to test them and or to look for the Logosoft manual. It has everything that you need, that you can read through and practice by connecting. So the software, if you place an input like that, you drag and drop, escape. Okay, you just click on it and then you go to where you want, actually not drag and drop, then you click wherever you want, and it enables you. The more you click, you will be able to replicate or to make more of those blocks that you have chose. If you press escape, you see after pressing escape nothing happens. So if you're not happy with these, then you therefore have to delete them. So now here's a basic program. So when I do this, I'm connecting the two. It tells me where the connection is coming from. Even when the program gets too complicated, you will be able to see where your input or your output from whatever block it's coming from. It gives you that address. So after connecting like this, you either can be able to cut, you can cut the two, and then here it tells you that this is you connected at Q1, and on this side it tells you that the connection comes from I1, and it tells you how many times you have connected it. Alright, and then if you want to join it again, you say escape and then click there and then right click, and then you can go to join partner, or you can be able to join again so that you can see your lines. This cutting mechanism really reduces the confusion that you can find whenever you are programming. At least you can sustain order. Order in programming is very important. Okay, and then this is for the text. If you have text that you would want to make, okay, all right, and then you are able also to edit the text. After pressing escape, you are able to edit the text. You can double click on it and then you will be able to edit the text as much as you want. You also given the chance to choose colors, and you are able to enlarge the size of it. Even inside every input or a block, you are able to make comments. You can write, this is a start button, start push button, and then you are able to change the number of input like that, and you are able to if you'll be using the program for simulating purposes, not controlling any real machinery, and you are therefore able to change the state of your inputs. In this current case, it is a switch. A switch, it switches from 0 to 1 and it stays like that. And then when it is a push button make, it has a spring return. If it would be a physical button, it would have a spring return. Therefore, when after pressing it, it will actually kick back and it will cut the signal. And then here it's a push button break and normally closed. So this one by default the current is passing through, therefore when you press it, it cuts the signal. This one is used mostly for whenever you want to demonstrate a push button for an emergency stop button. As you could know that by law it is required for you to use a normally closed push button or switch whenever you are doing the emergency stop buttons. So you are also able to change the text for this. You can make it bold if you want, you can use any color if you want. So you are able to also format. Right, escape. Just get used to pressing the escape, and then this functionality here, it is for whenever you want to simulate, you can just press on it, then you are able to simulate as I am doing right now. Right, and then this one only functions when you have downloaded the program, and then you'd be able to do the online test. So as you can see now, we didn't install any we didn't connect. First of all, we haven't yet connected it, and then even the PLC is not on, therefore, and we haven't downloaded the program to the interface. That's why it doesn't want to operate, but it's fine. So you go back to simulate again. You can simply press escape so that you could be on the programming mode. So you have the simulation mode, you have the programming mode, you have the online mode. So you have 3 different types of modes. All right, and then all right, so this is how the Siemens logo PLC looks like, and this is just the advanced learner kit that I have here. It is integrated with push buttons, analog switches there, and the PLC itself. So everything is connected to the PLC. Then I went to an extra mile of connecting push buttons. As you can see, I have 2 push buttons there and a motor there. So by default, you could only test the LEDs there, and that was not enough for me. So for demonstration purposes, it is best to go an extra mile I've therefore decided to redesign it to have the motor and to have the frequency, the variable frequency drive. This guy here is responsible for controlling the speed of the motor so that the motor doesn't run on its maximum RPM. You know that if the motor runs on their maximum RPMs for prolonged time, especially for an educational setup, it might find itself running for 8 hours, and it is not designed for to do that, especially at maximum speeds. Therefore it will end up exploding right in the middle of a session. Therefore you need to regulate the RPMs. So this VFD is designed, and I connected it to be responsible for regulating my speed so that they can run on a constant safe speed. For this video, I'm not planning to go deeper into the VFD. I am not demonstrating the VFD, I'm just demonstrating the basic or the introduction to PLC programming. Okay, for the PLC that we are using, it uses a USB connection, and the latest PLCs, they use the intranet cables, therefore they are connected on under the LAN, and this one you connect it directly to your laptop using the USB. Therefore you would need the drivers and the USB cable, and the USB cable needs to be connected onto the logo. Here is the USB cable. It comes from the PC and it goes directly here. So the latest versions, they use an intranet cable. Obviously, after making sure that everything is connected, and therefore you would have to download. Remember, the PLC needs to be on, and there are different types of PLCs even in this older version. Some they are using 240 volts, some are using the 12 volt. So in this one it's using a 12 volt, and the 12 volt the 24 volt I mean, and I'm getting it from the VFD. It has the output for 12 volt, so I don't need any extra 12 volt connected to the PLC. I took it from the VFD. Okay, so now I'm done downloading. I'm gonna go to online. Alright, this is how the online section looks like, and you are able to start or close operator monitoring. So when you press here, it enables you to monitor the real signal response of your machinery. So I'll just press it like that. Alright, so now when I press there, you see here what happens. Whenever I press the push button, the push button shows that there is current in it, and the output also, it shows that there is current in it. So now the unfortunate part is, when I observe on my screen, the LED doesn't illuminate properly because it's too bright in the room. Let me show you. I hope it will be visible. Yes, it doesn't show properly. It's too bright here. but the sound of the relays inside the PLC, you can tell that it is functioning. In general essence, whenever you are designing a program for a motor, you would only consider that, and then you would put your reset, and definitely your motor will run until you reset it. Say maybe you reset it according to I2, then your motor will run until I2 is pressed. But unfortunately, whenever you have the VFD, the situation changes. It depends how your VFD is, it's operational. But this one that I have, you need Q2 to enable the VFD to function, and you would need to a latching relay to do that. All right. After enabling the VFD to follow the sequencing of the program, and then you would need an input, a separate dedicated input to trigger that VFD. Okay, so before you can run, you must press I3, then I1, then after that the motor will run. But this motor will run straight up until 40 RPM, which is the maximum number of RPMs we have on the system, and the VFD can regulate that using the PLC, so that when it reaches that maximum VFD RPM, it should reset itself. So now this is the call for the analog input. So you have to know exactly which analog you have connected your analog switch on, or your analog dial on it. Or the potentiometer. So luckily our PLC has the potentiometer connected, and therefore we're gonna utilize it to control the maximum speed. The maximum speed set on the VFD is 45. It's 40 RPMs, and would say whenever the potentiometer reaches that maximum, its maximum, therefore the speed would be 45, and it will be around 950. Therefore it will have to cut the signal going to the enabler of the VFD, so that it can stop the motor from running. Okay, so we'll have to use a analog threshold. Okay, just like this. Then it will connect there to stop the enabler, and we want it also connect there, right, to assist the input I2, which is the stop button. But now we want it to switch off at 950 and switch on at 0. Therefore this is on by default, the threshold is on by default. Therefore this means we need to reset it there. Therefore whenever it switches off, it will change the signal there to be on, then it will switch on there. Even here it will change the signal to be on because of the invert, then it will switch off the output. So at 0 it is on, at 950 therefore it will switch off, then through the invert it will therefore switch on the reset. Alright, then this here we can see it's the stop button, and then this one here, okay, you can change the color to be red, bold and red, okay, and then this one is the potentiometer. Right, this is our analog dial that will regulate the speed. In case of students are using this, it is very important to have it. Then they will regulate their own speed, and whenever it gets to maximum, the machine will switch off safely. Right, then downloading the program. After downloading, you go to online. Alright, and then after that, so as you can see, the potentiometer here is on, therefore these are actually off, they're not on. They are assisting with resetting purposes, they are not on. And my mistake also here, I'm making this latching relay to be only dependent on the potentiometer to switch off, therefore that is wrong. I need to amend that. It must come from, it needs to come from there, okay, like that. Okay, I can take my stuff a bit closer. Okay, what is very important whenever you are programming to avoid any problems. So now if any of these two are triggered, the stop button on the potentiometer reaches its maximum, therefore both these going to switch off. Okay, right, let's see then. Need to make sure that I see that one. Okay, so now taking the potentiometer to 0, you see nothing happens to it. I'm taking it to maximum, you see it resets there. Alright, and then what I need now is the I3, trigger I3. So the enable is ready, and then I press the start button there. Alright, then as you can see the sounds, it tells you that there is a electromagnetic field building up into the motor, and then the more I increase, you see the sound is also increasing. Okay, the motor is now running. So unfortunately the motor don't just run with our minimum what you call this, with our minimum RPMs, it can only run from 20 RPM. So now it's around 34. I'm increasing the potentiometer until maximum. See now the potentiometer has passed the 950 mark and the motor has stopped. Then I'm taking down my potentiometer. So now the system is only safe if after shutting down it doesn't automatically continue running. You need to come and help it to run, because in complex systems it will be stuck because of something, and then next thing immediately you remove that thing and then it starts running immediately. That it's a risky situation. Therefore you don't need that. You need to make sure that you are the one who are able to come again and set everything so that you start afresh. All right. This is how it looks like. I'm gonna reset first. Okay, then I'm gonna set I3. Okay, I3 is ready. Then I'm gonna press I1 to start the system. Okay, and then there's a build-up in the of electromagnetic field in the motor, but it's not yet running. Since I said it only starts to run from 20 RPM, then I'm pushing up my potentiometer, then it's now at 20, but the motor needs a bit of a push, right? Now, okay, let me just increase it a little bit. All right, now it manages to run by itself. So then now when I increase the potentiometer, it's running very fast. You can even, you see the motor has started to vibrate. As I go up and up, I'm pushing the threshold, right? My VFD shows that it's now running at 40 RPM, at 39 RPM, and my potentiometer reads 940. At 950 it will cut that signal, and you can see that the motor is already vibrating, and the more I push up it reaches to 950 and it switches off immediately. All right. Okay, now I've splitted the screens. I'm going to show you with the split screens. So I'm going to reset to make sure that there is no problems. Then now I'm going to start I3. Okay, you see there at Q2 the enabler is ready, and then I'm going to go to a start button. All right, and there's a build up into the potentiometer, shows that it's not on its minimum. So let me drag it down to minimum. Now the potentiometer is at its minimum, and my VFD is also at a minimum. Now I'm increasing it. Okay, it's now around 20, 21 there. Then now I'm gonna boost my motor. So now my motor is running. Okay, now I'm going to increase the potentiometer. Right, the motor has started to vibrate. The motor is vibrating even more. Okay, now we are about to reach the maximum speed set by the VFD. Remember, if we didn't have the VFD, the motor would be running faster than this. Right, now we are reaching the maximum and the motor stops eventually. The system is designed to stop with either the stop button or the potentiometer. So I'm reducing down the potentiometer. And then this is the top view. Okay, so I'm going to start my i3. Okay, and then start my push button. You see my VFD is at 10 right now. Okay, now we are around the 24, 25. So the motor is ready to run. Right, the motor is running and the RPMs are at 25. Let's increase them with the potentiometer. HRPM. Yes, reached the maximum. Alright, I'm sure you have seen how the VFD affects the motor, and I really recommend using these drives whenever you are testing the motors, because they can really save you a lot trouble in terms of students. As you can see, my machine, my motor is not guttered. Whenever I run demonstration with students, I make sure they keep a safe distancing, and if they have to be the one operating the machine, I remove the blades, and yeah, so that they do not touch the moving blade. I know they they can touch the machine inappropriately, and make sure that I'm always with them. The recommended way of doing it is let them put the program, and you start the machine for them. They mustn't touch your machines, because the moment you remove your eyes from them, it's the opportunity for them to do whatever they like with the machine. So this system can also be used to control pumps. If you have a pump at home that just runs at maximum speed, you can use a VFD to control the speed of the pump, so that it doesn't just run at maximum speed, because it can easily overheat and it can easily burn out. Thank you.